Hello everyone, I am Erika Sinadhan and I am with Alpha May Hadrake, and we are going to discuss about how source measurements are made, particularly in sound fields and sound power. Let's start with sound fields. As you can see in this figure, sound field is a region in a material medium in which sound waves are being propagated. That means it is a region of an elastic medium containing sound waves. A good way of understanding sound field is to think of what happens if you were to pour water into a leaky bucket. If the holes in the bucket were only small, then the water would leak out slowly, and pouring the water in too fast would cause the bucket to overflow. This is a steady state situation where the rate at which sound energy is being lost is exactly balanced by the rate at which the water adds energy. Another concept in free field is the simple source. First is any vibrating object that will radiate sound into the air is called point source. Second is free field. Free field is uniform and is free from all bonding surfaces. Third is power level. Power level is a single measurement of the sound pressure level at a known distance from a point source. A good way of understanding point source is a sound coming from an inflated balloon that vibrates over its entire surface. This source radiates sound equally in all directions from the center of the balloon. Another concept in free field is directional source. In directional source, more sound is radiated in some directions. So these are the factors contributing to directional sound. In actual practice, noise sources are not as simple as point sources. So we use fishbone analysis to determine the causes of emitting directional sound. Cause number one, the sound is not radiated uniformly in all directions. Number two, the amplitude variation is not uniform. Number three, the sound source is not spherical compared to point source. And lastly, the time phase of the variation is not uniform. Now let us observe the sound field surrounding a large power distribution transformer as shown in this figure. The sound pressure contours around the transformer correspond to the indicated values of sound pressure level. This source is obviously directional since the contours are not circular. The figure shown here is an example of simulated free field. As you can see, only the direct sound from a source is measured. The free field does not occur in practice because of the effects of sound reflected from ground or floor, from nearby objects, and from walls and ceiling. Such an environment is known as a simulated free field. Next is the effect of reflections in a room, particularly in reverberation room. Reverberation occurs when a sound is reflected, causing numerous reflections to build up and then decay as sound is absorbed by the surfaces of objects in the space, which could include furniture, air, or people. Next is the measurement of sound near a source. The device used in measuring the sound level is decibel meter, as you can see on the left side of the screen. It may be suspended in an anechoic room. This measurement microphone is frequently set at a series of positions spaced 1 meter from the major surfaces of the device. The observer should not close to the microphone when the measurement is made.